Hi everyone, and welcome to today's session about TaskGen. So recently, I've been spending a lot of time on TaskGen to refine the prompts, make it better. So now it can handle more and more arbitrary tasks. And I also make the function integration with TaskGen much better. So any Python function can be fed to an agent now. So just a recap for those who don't know what TaskGen. TaskGen is basically a way to take a task and then based on the equipped functions that the agent has, basically the abilities of the agent, is able to match the subtasks, basically split the task into subtasks, match the subtasks to the equipped functions to use it. The function will return an output, and then this will go back to the meta agent for the next step and so on. You can also assign an inner agent to this meta agent, which means that instead of giving a function, you can have a function which is the agent, another agent to execute another task. Like maybe this agent does very well for like code stuff, then you can get all the code stuff to this agent. Another agent can do very well for math stuff, you can put all the math to that agent and so on. So all in all, TaskGen is a framework where you keep doing subtasks and eventually the agent will decide, okay, I've done everything, let's end the task. So all this, the main thing is about how we define our functions and how we equip it to expand the capabilities of the agent. And also another thing is to minimize context length as much as possible, because research has shown that the longer your context length, the more the agent hallucinates, like it gives incorrect stuff. It also means that if you have a long context, large number of functions, and you pass all your output to the same flow, which is what most React agents do. They put the thoughts observation action, all the past thoughts observation action will go to the agent. This might lead to hallucination, and these are not that great. So TaskGen, the main insight that I have is to try to reduce what each agent sees, or each part of the process will only see a small section of the whole slice of what's going on, so as to get more concise and more accurate output. Okay, so today's session will mainly focus on functions, external functions. And let's take a look here. So external functions are like this. Okay, so before we start, this is the key stuff to do for TaskGen. Okay, don't need random. You just need to import like OS import from TaskGen import stuff, because you can then import all the necessary things that you need for TaskGen here. Okay, before that, you can pip install to get the latest version of TaskGen. This is version 2.3.0 that I'm using now. So next up, okay, this one is actually my actual API key, so I'm not going to open it. So you have to put your own OpenAI API key here. If you don't want to use OpenAI, that's not a problem. You can also define your own custom LLM for TaskGen, okay, or StrictJSON. So what you do over here is you basically import whatever you need from your own from your own LLM here. You take in a system prompt and a user prompt as a string. You put it into the format that's required for your own LLM, and you return the string of the output for this. So if you look here, this is the custom LLM that costs GPT 3.5 Turbo. You can see that if you just put custom LLM like system prompt is, you are a classifier, and the user prompt is, it is a hot and sunny day. Okay, so you are a classifier to classify the sentiment of a sentence. Yeah, something like that. You can run this, and you can see this is like positive. So essentially, we are feeding this custom LLM into TaskGen itself, so that TaskGen can use this whenever it needs the large language model. It can give it a system prompt and a user prompt, okay, which is already predefined in the schema of TaskGen. Like the system prompt will be like your system prompting message. User prompt will be like the input of your functions and so on. So this is already predefined in the TaskGen schema. If you're interested, you can take a look at the base.py and see how it's done. Function.py. I split the function. You can see that we basically do a strict JSON for every time we use a function. Yeah. So sorry, it's not here. It's down there. I use the external function somewhere. So yeah, this is an internal function. We do a strict JSON for internal function, and external function, we pass it to the external function. So over here, you can also see there's stuff like shared variables, which means that, you can have persistent states that are passed on to the functions as well. So yeah, there's quite a lot of interesting things that are happening here. So let's go through them. So first up, okay, before I continue, any questions so far for like the interfacing of TaskGen? Okay. So next, we have how to interface functions with TaskGen. So previously, if you have seen the rest of the videos that I have earlier, you have to define a function for every external function, and then the function, you will need to have the function description. So you need to put like appends num1 to numList. So this was how it's done previously. So you have a function description here, you have an external function, and then you have like maybe like, okay, that's that, and then you have the output format is this. Maybe you can have out list and then list of numbers. You can okay, yeah, like that. So this is the previous way of doing the function, which still works, by the way. So you can see that how this is done is like this. The function description is over here, and you put in angle brackets whatever you have for your inputs here that needs the LLM to fill up. All right, so you see the description is like that. The input will be the list of input variables for the LLM. So basically, I did it twice. Okay, why? All right, the first one up here is to do more in context identification for the LLM to know, okay, the variable appears here and the variable appears here. So it's better than, you know, if you were to do something like that. Appends, imagine if you do like this, appends number to number list, then inputs, you can put num1, num list. Okay, and you can tell me if I do like this versus how I did earlier just now. What's the difference between doing this way and doing the earlier way? Anyone want to guess? Like, so the other way was like this. The other way is to do it like this. Okay, anyone want to chime in? Like, which way do you think is better, the top one or the bottom one? Yeah,
I think
so
the top one is more descriptive. So from an LLM point of view, emphasizing the type of the list is useful. Like num list, it might guess, it might not. So there's the type information is, in my mind, probably very useful.
sorry, you mean type as in the integer?
So we've got in
like
line 43. So yeah, so now you've actually added full type information, right? So that would alleviate the issue. So the issue is if you don't have type information of some sort, then the LLM is left to guess what type you mean.
Oh, correct. So actually,
right? So
I wanted to compare not the type. So assuming the type is there, as in this phrasing or this phrasing, which one do you think is easier for the LLM to understand?
I like the second one more, but I haven't tried the experiment.
Right. So most existing agentic frameworks use format 1 here. So LangChain, CrewAI, and so on. So the description has nothing to do with your input variables. The input variables are in some params, which are separately handled. So I didn't quite like this style. Is because you look here, there's extra cognitive effort needed for the LLM to do this. So you see appends number to number list. So it needs to match this number to this variable here, which may be differently named from your variables here. So if you do it in this form, the LLM knows, oh, I append this variable to this variable. To me, it's much clearer than having to guess which input variable match to this. So I've adopted this for TaskGen and StrictJSON. This is the format that is required. You must put your input variables in angle brackets in the description here. Okay, that was TaskGen V1 or v2.0. In TaskGen v2.3, which is the current version, I have decided to make the whole process easier. Why have you fill up so much here when I can infer for you? So I've done some testing and the performance was about the same. So let me show you the new and greatest TaskGen. So this is TaskGen v2.3. So maybe I put here, this is TaskGen v1. Okay, so the TaskGen v2.3, what you need to do is you can just basically put this as a function. And then you can put the external function is this. And you can see all these are done automatically for you. As long as you have a doc string here, okay, we will do this for you. As long as you have the types here, we will put the types in for you. As long as you have some output types here that you want in the signature, we will put the output type here, and we just call it a generic output one. Okay, previously you can see that, we described the output, but I realized that just like this is good enough for the LLM also. So, I don't have to trouble you to write an extra function wrapper for your own external functions. Take whatever Python function you want. Take whatever Python function you have. Just pass it to the function as an external function like that. Done. Okay, we have a function that can be used for TaskGen already. And you can even run the function like that. You can just run like that function for, and then like the list is like that, 2, 3 maybe. And you can see the output is straight away generated. This is a deterministic function using this. Okay, so this is the change in TaskGen v2.3, which is what I'm showing today. You can just put whatever you want over here, and this would appear in the function description already. Okay, the name of the function will just use the name that you have in your. Okay, you can see the function name. The name is just basically the name of this external function. So what this unlocks is that you can use any external functions you have, and even from LangChain, Crew.AI, LangGraph, whatever external functions, as long as it's of this format, which has a definition, some docstring here, you can just plug and play into TaskGen. Okay, just a caveat, it doesn't work for class-based functions. So basically, if you have a class and you have an init and a run method, you can't infer the function signature like that. So it's best to wrap it over. So if let's say you have a class-based method, so your class-based method here. So you might have to do your own wrapper. So you might have to wrap around a function definition like that, but it makes life very easy because after you do your function definition, you can actually just plug this function to your agent. Okay, I'm just showing you here as to how internally we will process this function. So let's say if I just, delete away this thing here. So if you delete away the docstring, we'll just, add it to docstring smartly. So it won't break if you miss out certain stuff. And over here, instead of having a function description, because we don't know what this function is doing, we just put inputs. Okay, of course, I could also use GPT to, look through your whole code and infer the description. I've chosen not to do that because your code can be quite long, and, I would want to encourage everyone to put a docstring there to describe what your code is doing. Yeah, so this is what is going to happen. And, if let's say you miss out, you don't match exactly this one. So what will happen is like that. Num1 not in the docstring. Okay, we will just put at the back the inputs here. So this is a fail-safe, okay, so that if you miss out certain stuff, the function will still work. Okay, what if you miss out the types? No problem. If you miss out the types, you'll just have no type over here. Yeah. If you miss out the output, no problem. You have no output here. So it's made to be quite versatile. And this basically can handle a lot of things that, if your function definition is not done properly, it can still work. And to the agent wise, of course, the more details you put in, like in terms of the types, the better the adherence. But it still won't fail even if you don't put in the types. Okay, it will still be able to at least work if your description is good enough. So any questions for this? Because I think this is the biggest feature that has been created for TaskGen v2.3. Is the automatic passing of any Python function into the format needed for TaskGen. I pause here for 1 minute if you all have any questions you want to ask.
I think the challenge is to move it from the trivial to the, real version. And for mine, one of the challenges I've had is to figure out when it should be a sub-agent versus a function. But that's
okay. So that's a design question.
It is. It's a bit different to this, but in terms of this interface, no, it looks solid to me. I mean, the question around args and keyword arguments, it's a bit of a. Are they necessary in this case, or are they just?
Oh, no. You don't have to put this. I'm just illustrating. Okay. We don't care about args and clucks. And okay. If you also put shared variables here, we will ignore it as well, because shared variables is actually, if you want to access the agent's internal state or so on, you can use the shared variables to do it. So this allows for some form. Other people call it scratchpad. So basically, it's a way to pass on persistent states to your functions. So we also ignore that as well in your function definition. So like that, yeah. So so basically all you need is just the two main variables that we have. All right. Any other questions before I move on to the exciting bits? So this is
if I use things which are complex types rather than just an int in this case, does that still hold, or will it marshal those types?
So you have to see what what is support, because I didn't like Pydantic, because Pydantic is very verbose. Like StrictJSON can do Pydantic in like at least less than half the tokens. So, but it comes with some catch. The catch is that it only works for a few existing data types like this. So you cannot have stuff that are like not supported by this. So
Okay.
not all typing works, but I think this covers like a lot of use cases already. If you want more types, let me know. I see whether I can implement it. But yeah, it doesn't work for all the typing, because over here I use typing, right? It doesn't work for all Python types, but it works for most generic types like list, dictionary, integer, float, string, boolean. Yeah. You can also do like that, list, boolean, you know? Yeah. As long as it's supported by TaskGen, it will appear here. If you do a type that's not supported by TaskGen, like maybe agent, okay, it will still appear here, but later on it won't be processed. Like we won't do a strict type checking for this unsupported types of strict JSON.
I see. So it won't prevent it working, but it may affect the capability, the reliability.
Correct. Yeah, but based on what I've seen so far, I think most of the agentic frameworks, also the input types to the functions are all simple types. So this shouldn't affect too much. In fact, because of using strict JSON, you save a lot of tokens and your inference time will be better also, and performance also likely will be better. So at least that's how I try to think about this. Yeah, I really don't like Pydantic. It's too much. The JSON schema is too long. I don't know if you all seen the JSON schema before, but it's just one bunch of text. Yeah, well, all you need to do is really just like something like that. Yeah. Okay, so I move on. So how do we do this function to an agent? All right, so that's the cool part, right? So first for agent, how to define an agent? So agent is defined like this: agent name, agent description. Of course, there's more stuff, but I'm just going for the basics. Agent name, description. And if you want to use your LLM, you can just custom your LLM put here. So this is ChatGPT 3.5. Okay. And if you don't put this, we will by default go to OpenAI's ChatGPT. Right. So we can assign our functions. And over here, the function we assign is this add number to list. Notice that once we assign this function, we don't need to assign this thing here, because inside here, we will do the function conversion automatically. So if you list the functions, or in this case, let's print the functions to see it better. You can see that we have this add number to list. Done. Beautiful. You just need to define a Python function. If I want to define more functions here, like maybe define, I don't know, multiply two numbers, we can do like that. We can do a multiply two numbers like that. I can even do something like this. If let's say I want to use an LLM, like convert number to word. Okay, so what I do is I can do another function like that, equals to function. Okay, converts num type integer to word. All right, and then over here we put external function. Sorry, no, this is just the function description, and then the output format will be output word of the number, and then over here we put let's see, yeah, we can put a function name here. So function name is okay. If we don't put a function name, no problem. We will still be able to pass it. It's just that we will use the internal LM to generate a name for you. So over here, I just make it deterministic. So this is an internal function. So this uses StrictJSON to generate an output. So I mean, just to show you how it works, you can just take this convert number to word, and then you just pass it like maybe 4. And then you see the output is 4. Okay, so we have 3 functions right now. Okay, let me just put this thing up here so that we don't confuse people next time when they have. So you have 2 functions right here. And I'm going to put all these functions inside. So we have put multiply 2 numbers. And then we put convert number to word. So it's very flexible. You can do either an LM help you do the function, or you can define the function yourself. Or, if you want to do a hybrid, you can even call a StrictJSON function here. Or you can put a function inside here to, do some LM stuff and then do some rule-based stuff. So your function is a combination of both rules or deterministic statements as well as LMs. You can do all of that here. So I'm just going to pass in all this to the agent. And you can see right now, we have this output. Over here, we have some issues. Here, the num1 is not in the doc string of multiply two numbers. So you can see I forgot to define my doc string here, but not a problem. Okay, I'm just going to leave it here. Not a problem because your function name itself is quite clear already. So let's run the task. So right, append 7 to 24. All right. So now the math is okay. So this is another advancement of TaskGen 2.3. Okay, so let me just see whether this ends. Okay, I hope it ends. Okay, so this is ChatGPT, so it doesn't end it immediately. Okay, if it's GPT-4, it will know that okay, the task has ended. But you see, it still did the task. All right, it appended this 7 to this list here. So I want to emphasize a bit here of what's going on, because this is another big improvement. For those who don't know, the previous version of TaskGen is actually, it will generate a list of steps, and then it will adhere every single step to do it properly. And once all the steps are done, it will end the task. I found that this method is a bit too restrictive. So if I already give the agent a list of steps, or ask the agent to split the list of steps and follow that list, when the output comes out and the output fails, all right, it won't redo that step again with another input parameter. It will just move to the next step. So it means that your steps, if let's say there's some error in the steps, okay, let's say the step doesn't work properly, your agent won't be able to fix it. So I spent about 2 months trying to rejig the prompt, and this is what I came up with. Quite similar to the React agent in LangChain, but it's different because the way I prompted it is quite different. Here, the observation is not the observation of the function that you call. The observation is the agent reflecting on all the past subtasks it has completed, and then it thinks, how far away am I from the goal, or like, what have I done so far so this basically grounds the thoughts. So the thoughts has been prompted to say that, given your observation, what do I need to do to complete the task? So it's a chain of thought process. So this observation is different from what people call observation in chain of thought. This observation is the agent reflecting on its task completion status, right? And this thoughts is what to do next in detail. So you can see this is what the agent has thought about. And this tool will ground the subtask identified, which basically has been prompted to say that, hey, given what needs to be done here, find out what can be done with one single function and do it next. So this is what is done here. And then we'll call the function. And then once we call the function, because sometimes these input parameters might differ from what the subtask identified. So it's like, sometimes your boss tells you to do stuff like, go write me an email. Then once you write the email, you realize, hey, actually it's not an email that I need to write. Or go write me an email on topic X. Then as you're writing the email on topic X, you realize, hey, actually I should be writing on topic Y instead, because topic Y suits the task better. So that I have built a function in 2.3 that once we call this external function, we will also update the subtask identified to make it suit whatever has been called here. So if your boss asks you like append 3 to the list, and then you realize, hey, actually it should be append 7. So this will return back here, and basically this subtask identified that you see is after this function call has been decided, the parameters, we also update another subtask description to put it back here to make it grounded in what has actually happened. So this improvement actually made the agent look better. So this is quite cool because the function parameters will update what the subtask identified is. All right. And you can see this continues on and on and on until the thought say, okay, we should end the task. So I'm just going to dive a little bit into the details here because I think most of y'all haven't seen it because it just happened a few days back. So how is this done? So this took 2 months, by the way, to refine this. So it wasn't easy. Yeah. So the beauty is over here. The beauty is in this get next subtask. So we firstly give it what's the task, what has been the subtask completed. Okay, so subtask completed is basically a dictionary of whatever has been done, the task name as well as the task outcome. So I just show you what subtask completed here. So you can just see. So this is the subtask name and this is the subtask output, all in the dictionary format. Why dictionary format and why not list format? It's because at first I didn't want to repeat the subtask. Okay, but after a while I changed my mind. I thought, okay, maybe sometimes you need to repeat. So So actually, this could also be a list format. That doesn't need to be a dictionary, but the idea is it stores what is the task and what's the output. Okay, notice that I didn't store the observation and thoughts because this can be very lengthy. And honestly, the previous observation can affect the later observation also. So it's best not to put that in. So this is a very concise view. Again, TaskGen is all about conciseness. Only present what the agent needs at that point of time. So this subtask completed is just a very concise view of what has happened. Okay, back to the agent itself. So we have the subtask completed. We pass in all our memory. So another key feature of TaskGen is memory. You can prime it with what has been done correctly in the past, what the experts has given. You can just give different memories. One day I'll talk more about memory. That will be a separate session on itself. You can have different abstraction spaces for memory to ground your agent. So this is the memory part. So what is the prompt? Okay, how to select the equip function. So if you notice, the prompt here is very short compared to last time. Last time I was like twice the length. Okay, and I realized that the smaller LLMs like ChatGPT can't handle it that well. So I made it so that the baseline of TaskGen is that it should be able to run on ChatGPT. So if you use models that are similar to ChatGPT, it will work for most tasks. But if you are doing code generation stuff, please use a better model like GPT-4 because the baseline LLM matters a lot for how well it does the task. Okay, so this is the key thing. Provide what's the current subtask and the corresponding equip function to complete the part of the assigned task. All right, the last part is to end the task. And over here, I also put you are only given the assigned task from user with no further inputs. Because in the latest version of ChatGPT, it apparently has been trained to be a personal assistant. It will just tell me no input given by user. Hence, I cannot do the task. Okay, but we are not having a dynamic version of the assistant right now. So that's why I say you are only given the assigned task. You don't expect any other inputs from the user. Right, so what do we need to get? We reflect on what has been done in subtask completed and say what has been done so far. And then this will be used to ground what to do next. Brainstorm on how to complete remainder of assigned tasks in detail, given this observation and the subtask completed earlier. So notice the words I use, brainstorm. All right, this matters. Okay, if you just put like how to complete, it might give you very like you won't think too much. But if you ask it to brainstorm, again, this is prompt engineering. It helps to generate more diverse thinking. Like it will actually think out loud more. All right, and this is grounded in what we have so far: observation and subtask completed. Okay, then after that, we have this. After these thoughts, we ask, what should I do now with only one equip function? And then finally, what's the name of the equip function? So it's all going through a sequential flow. All right. Question so far for this flow, because this, I think, is the defining feature of TaskGen. Like, this is not easy to generate. Okay, this took 2 months plus to get it to the current state right now. Okay, before that, it wasn't like that. So, question so far for this?
I think mine's really around that. So you touched on the sort of linear nature of it and how, because LLMs aren't really in their own nature linear. So they're sort of a parallel kind of approach in my mind, right? There's context driven. So I haven't been tried this version yet. So I'm sort of just wondering what are the challenges that got you to get this outcome? So I take your point that it's a lot of work went into it, but what was it? I guess how did it go wrong that this was the right answer?
Oh, yeah. In the last 2 weeks ago, when I was demonstrating TaskGen, I tried to do some cooking recipes, and I realized that it was too linear in the sense that it just did whatever the user stated, which means that the kind of task that TaskGen could handle in the past, you need to specify quite clearly what the task is in your user task. And I didn't really want that because this means that your user needs to know how to prompt it well. So I wanted a more robust, more generic kind of way to think about tasks and to generate them. So I decided that, like the agent needs to know how to do error handling and how to, if let's say the environment gives back some inputs that it doesn't know or it doesn't want, it knows how to handle separately. So the old way of following the list wasn't adequate. That's why I spent quite hard. If you look at the Discord, I even tried to do like Oracle and stuff like that. I tried like almost 20 different versions of this prompt, and this is the best performing one. So back to the old React framework. So whoever did the React paper, great job to y'all. your React method is still the best. Yeah, so I don't know if that answered your question, Richard.
I think so. Yeah, I mean, I guess that's. I mean, I'm very keen to learn from other people's mistakes as well, but also, those what you're saying about the different patterns of, I think those are going to become some of those things that we come back to again and again, right? Is it
Yeah,
Oracle pattern? Is it React? Is it what have you?
correct. The Oracle was too assuming. So if I put the word Oracle there, it performed well for some tasks. But then if let's say the task requires a bit more versatile thinking, the Oracle will think that it knows the answer. And then it won't explore enough. So this prompt here, by the way, although it doesn't like follow a list or what, because of the way it's doing its thoughts, it can actually come out with the list and the thoughts as well. So it's not too bad. But stay tuned for future updates of TaskGen. There will be a planner module that will put in rule-based plans, or like at least do the split into different subtasks in the planning stage, so that this agent only needs to handle one small part of the plan, and it can brainstorm how to do that part of the plan better. So there will be an extra step to do planning in future TaskGen versions. So that will boost the capabilities of TaskGen to handle even more complex tasks. But right now for this, suitable for tasks that needs about 5-6 steps, it should be able to do it. Okay, so I have one last part to talk about before I go back to the worksheet, so to the Jupyter notebook. So I actually do type checking for the equip function, okay, by doing a StrictJSON call. So this is actually a StrictJSON call under the hood. So we actually, based on the thoughts that we have, the current subtask that has been chosen, the equip function that has been chosen, okay, I ask the LLM to put in the values, and I rewrite an actual subtask, okay, that states the actual input value parameters according to what is actually done. All right, and make sure it's detailed and can be interpreted without reference to any context. Why is this necessary? Okay, it's necessary because the agent doesn't see the thoughts that happens before. So if you notice here, the agent only sees this subtask completed. So we want to make sure that this subtask completed captures adequately what has been done. All right, if not, you see over here, this is illustration that, because you don't have the earlier thoughts, sometimes it thinks that it hasn't done that step. So, but this is actually a limitation of ChatGPT. Like if you look here, the next step is to append 7 to the list. Okay, but over here, the task has been completed already. This part for thought should actually end the thing. Let me just show you. If I were to change this to I just use model equals to GPT 4.0. I just use 4.0. And we can see when it runs here. Okay, so it's a little slower. So we do add number to list, and then we end the task. So that was a limitation in ChatGPT understanding what has happened. Okay, so ChatGPT is not a very good agent, but just to make it accessible to people, I have made TaskGen. I have tried really, really hard to make TaskGen work with ChatGPT. So if you can access GPT-4 onwards or Claude, those, even Llama 3 is better than ChatGPT. Try to use those. Okay, ChatGPT is like the base. Oh, it works now. Oh. So yeah, so this is what. All right. So the other thing I like to show is, like, you see now we have so many functions here. Let's try to go crazy. All right. Let's use more stuff. So in order to do another set of tasks, we can just do agent.reset, and you can see the agent status here. The agent status is nothing. No subtask has been completed. So let's try to run something. Okay. You want to give a task? If not, I'll just come up with the task myself. So multiply. Okay, maybe we ask, what is 101 times 100 converted? Answer this as a word. Okay, let's see how it works. Okay, I haven't tried this before. So first we have multiply two numbers. Okay, great. Let's convert to word 10,100. Is that correct? Yeah. All right. So again, ChatGPT, may not know how to end it. So after you finish your task, you just need to do agent.reply user. Okay, notice the reply user is not part of the subtasks here, because what I want to do is like a more modular framework in case you're doing your chat assistant and sometimes, you may not need to reply the user all the time. So you can just do your task here and, these are what has been done. And the moment you need to reply the user, you can just call the reply user function, and then this will give a response based on, again, the subtask completed here. It will give a response to the user like that. Yeah, so this is at least the framework of how it's done. So you run your task. So when you run your task, this is independent of the user. You don't expect a user reply from this. So you can treat this process as gathering information so that you can answer your user. And then after that, you answer your user. So you can see this use two functions, the multiply function and the convert number to word function. And, compared to LangChain, this actually handles functions with multiple inputs better. Right? LangChain, most of the time, only has one input. All right, you can do multiple inputs and so on. So as you can see, it's very easy to do it. Agent name, agent description, whatever LM you want to use. All right, then after that, you do all the functions you want to put here. And your functions may not even have a description, but try to do a description. Okay, a description helps a lot with the matching because we'll do name and description matching. If there's more than like 5 functions, we'll do rec on the functions. Okay, so this is the kind of things that you need to watch out for. We have 2 base functions here. One is use LLM. So use LLM is when no other function here can do the task, and here there's end task also after task is completed. So like when is the use LLM function going to be called? It's like that. Agent.reset, agent.run, list me 10 reasons, or give me 3 reasons why I should use vectors instead of scalars. Something like that. Yeah. So let's see whether it knows how to call. So just put this up here. So the first reason is using LM to call. This is the first reason. Second reason is like this, because scalars can be edited. And then third reason is this. So we can see that the subtask completed, actually this is the subtask completed. These are these are the outputs for the sub. So you can see agent.subtask completed. You can see this is the list of tasks that has been generated. And now we can answer the user. So you can just look. Okay, notice we don't, so this is the answer. So you notice you don't have to just do this format. You can also say, why should I use vectors? Or you can even ask like, this is a QA bot. List me the key reason why vectors are good in the style of a poem. You can just write like that. So this basically answers based on what we have. So you can see over here. Yeah. So they take complex quantities and yeah. So basically this reply user is quite versatile. You can just like treat it as a chatbot. You can ask whatever you want here, and then it will take whatever we have for the subtask completed and come up with an answer for you that is grounded on the subtask completed. Questions so far for this? Yeah. Okay, so now the more interesting part. Existing framework like Crew.AI, I don't know if you heard of it. They have quite a lot of nice stuff like talk to PDF and so on. Yeah, it's really nice to, take some of their tools and use it. So I've made that possible. So you can just take their tools, okay? How do you take external tools to interface with TaskGen? You just make a function that takes in an input that you want, import the tool inside here, initialize the tool over here, and then you just run the tool here. So you can see that the script website tool takes in the URL here, so we can just whatever function imports and definitions here, you just do it here and just return the output of the tool. So essentially, we wrap this entire tool from an external source into a Python function, and that's it. That's really it. Yeah, this is all you need to do the script website tool, and now you can use it in TaskGen. Query PDF tool is just to take a PDF from a file path and then run a query. So here, we can get the React paper. All right, so we take a look at this. This is actually the PDF for the React paper. So you just put you here, and you can take a look. So this is synergizing reasoning and acting in language models. Great paper, by the way. I still cannot beat their method, at least the kind of prompting that is used here. So this is the React paper, and then if you look here, the paper is down here already. So what we can do is we can ask the PDF like, okay, what is React? So this is the content that's generated. Okay, then you can use this content to reply the user. So we can create an agent for that. We can just call an agent, a PDF query agent, references. You don't even need to put the file name here. If you have more than one PDF, as long as your task mentions the PDF name, it can reference already. Okay, in the future, once I integrate with like the directory read, you can even read your directory and get all the files that you have in your directory, and then you can say, what is React? Then it can perhaps look at your directory names and then find the right file, open the file. All this can be done automated. Yeah, but I tried the directory read tool, it failed for me. So hopefully once they fix it, we can just take their tool and use it. So I like the CrewAI tools. They're quite nice. You can go check it out. Right. So this is the thing out. So I call an agent, put it the query PDF tool. I ask it what is React. So let's see what it gets. All right. So it calls the file path react.pdf with the query React. Okay. And then the query has been completed. So we have this. Now time to reply the user. So what is React? It's a unique approach that integrates decision-making and reasoning capabilities to a large language model. Not bad. I mean, it took from here. Yeah. So you can ask it other questions also. Like let's ask it like, I don't know. What do you want to find out about the React paper? What are the benchmarks used? I should have resetted the agent first. Okay, but in this case, right, so the benchmarks I hope is over here. So it depends on whether this rec works. So it query React benchmarks. Right. So there's also this thing called auto summary. So because sometimes your number of subtasks can be very long, and this might overwhelm the context of your model. So by default, auto summary kicks in after 3 subtasks. So you can see this auto summary is here. Summarize subtask count. So once we hit a certain summarize subtask count, so this is a new feature in 2.3 also. Once we hit a certain summarize subtask count, we will auto summarize the whatever has been done, and the auto summary is basically replying the user. So whatever you put in your task, it will reply the user whatever you ask. So based on this, it condenses whatever you have gathered into a very concise state, which you can then use to continue your. So over here we query the benchmarks and so on. So unfortunately, ChatGPT didn't know that it's time to stop. Okay, but no worries. If you put like the num subtask over here, you can just maybe like put num subtask is 2, it will stop after 2 tries. So, okay. So this is an example of how the JSON sometimes doesn't work properly, and StrictJSON does error correction automatically for you. So yeah, this is a good showcase of it. So, all right, so we have this one. So what they have done is like this. They have queried the file and they have summarized it. And let's reply the user and we can see what are the benchmarks used. And let's see. Yep, it includes Hotpot QA and Fever. All right, they also have Alpha actually. I'm not sure whether Alpha appeared up there. Yeah, so this is an issue that the rec here is not done enough. So maybe if we increase the number of sources we return back from the PDF, we can answer like the benchmarks they use like Alpha and so on. But this is just an illustration to show like you just integrate the right tool you want and it works off the shelf most of the time. You don't have to define backstory, don't have to talk a lengthy description, just say what you want. And define the agent name, agent description, and then your task here. That's it. All right. So I'll show you another example. So this is a website summarizer. So you script and use LM to summarize website to the user. Let's over here we use GPT-4o, but we can use other models as well. Okay, because we kind of want better output, so we use 4o. I mean, I can take it out and you can see that the ChatGPT. All right, let's just show you ChatGPT. So let's ask what are the differences between this TaskGen, all right, and CrewAI. So here I gave it the script website too. So let's run it and see what the agent does. So to complete assigned tasks, we need to scrape data. So we went to the website, we scrape the data, blah, 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 right? not bad actually, the script website too. Yeah. And then we will go to CrewAI, we script the data, blah, 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 blah. And then we compare the role-based design task management. And so this is the kind of data we have, compare the differences. So the more details you put into your task up here, the better you get for your generation. So please, if you want a very, very detailed output, spam this task here with as much details as you want. And the agent will ground its decision making on whatever task you specify here. So let's see what the output is. Okay, the complete remainder, we can focus on extracting more specific details and so on. So over here, we have the auto summary that kicks in. All right, and then we can ask like, what are the key imports needed? Okay, so over here, the auto summary has removed away the key imports. Okay, so this is something that we may not want the auto summary for. So let me just change the thing. So let's do 5 so it doesn't auto summarize. All right. And we run this again. Okay, so while it's running, I will take some questions here. Do you all have anything you want to ask so far about what you have seen so far of the external functions or like TaskGen in general? Yeah, anyway, now
I think that the challenge for mine is sort of debugging the process, right? So there's a lot of content that comes back when we run these. And I guess it's the challenge of how do we it's debugging it, right? So it's a system that does what it does, and that's great. But as a user point of view, it's quite tricky to figure out when it's working well and when it's working poorly. That makes sense.
Indeed. So like the evaluation is a tricky bit. But if your agentic framework, you give it the right functions to use already, the chance of it using the right one is quite high, especially if you describe it well. And I think for eval-wise, there's no other way to do it other than having a lot of examples and then just checking whether it works. Yeah, a lot of example tasks and then checking whether it works. In order to optimize the process, you can make the description a bit more specific. Like in your agent description, you can put like more stuff about here, like how to handle different cases if needed, right? And in your tasks, you can also make it a bit more specific. So that's like how to make the reliability a bit better. But you can see ChatGPT compared to the GPT-4, the quality is a bit different. It's quite different actually. GPT-4 gave me a nice essay answer. You see, ChatGPT just gave very, very brief summary, but this is still correct. So cool. Yeah, that's a website scraper directly from CrewAI, just like that. All right. So next we have like LangChain structured tools. Okay, I'm going to skip this bit. This basically saying that, you can have the add tool for LangChain. As long as you do an add tool, okay, maybe I'll just show you. So you see over here, this is a LangChain function. But if I just put add.func, this will become a function like that. Okay, which I can then like do like this. Right. So add.func is basically getting back this thing here. And you can just assign your agent the functions like that. And then you can just run something like this, calculate 3 times 5 plus 3, because it has these two functions. Okay, in the end, I went through the example, but the idea is, you could do LangChain functions like this just by doing func, and no extra work needed on your end. If it's this kind of methods, you can just straight away plug and play into TaskGen. Okay, so over here, you see ChatGPT not that great with math, all right? So it continued to add, but thankfully the auto summary helped to save it. So it's 18. Okay, so LangChain community tools. All right, so there are better tools that LangChain has. Okay, but honestly, I feel like CrewAI tools are better. So, but let's say if you want to use a LangChain tool, because so many people have created their own tools, same process, create your own function, put the doc string here that matches like this input. See over here. Do all your necessary imports here and then return these two outputs. So you can see like Wikipedia too, we can ask it to say who is Joe Biden. Like, and this is the summary. I mean, it's actually much longer. I just cut it. DuckDuckGo is to search the web. However, I did not run this because the rate limit has reached for DuckDuckGo. Right? So if you want to use a search tool, I recommend the Sub API tool. which you need Google Sub API for. So the Python REPL tool is basically you can execute code here. So you can execute any arbitrary code here. Okay, at first I was quite impressed with this tool. Then I realized that there's a lot of problems with this. It doesn't run a lot of code. So the benefit of everyone, I've created our own code tools for TaskGen. So you can use this as and when you like. All right, so Python generator tool is to generate code based on an instruction. So explicitly list all the imports and define the variables. You can only import these modules. All right, so I restricted it because I don't want the code to go havoc and hack your computer. Yeah, so you only restrict it to certain modules to limit the damage. Okay, best done in a sandbox environment. So this is a sandbox environment I've created to like limit the number of modules you can use. You don't use equip functions in this tool. Okay, ensure all required output and print statements because we don't want to like modify files and everything. So
I think putting on my pen testing hat, this is like it's. I'm not saying no. I'm just saying there's so many caveats on using this that you have to be really like, just for a start, don't ever allow anything that originated outside your control to get near that function, because a jailbreak, as you've shown previously, John, is really not that hard.
Yeah,
and and just the imports you've got there, sys, IO, those ones are quite sufficient to take control of your PC.
With this functions here?
Well, with this, it says run Python tool down here. It has import sys, import, or just IO for a start, right? Just any kind of.
You're talking about this, is it?
Yeah.
The LLM doesn't have access to this too.
But even if you didn't, I'm pretty sure I can get NumPy to give me access to files, right? Or pandas for that matter.
Then take away those.
Yeah. So that's the thing, is the attack surface is quite big, and that's assuming everything's working correctly, right? So a malicious actor could use this really quite maliciously, right? And so it has to be done. This type of thing is you need to be super careful with, in terms of where does the inputs come from that you're allowing in. They have to really, it's a, like, code injection is a classic tool.
Maybe if
for
there's a way to block file access, then that would be great. So I can go.
Well, yeah, that's only, you do that as well. It's just that it's a potential security problem, which is where the potential is almost unlimited.
No problem.
Right. So that and that's not don't use it, but do use with tremendous care. Right.
You have just volunteered yourself to put the security bits for this. All right.
No, I just did not.
Thank you, Richard. So we'll make it more secure. All right, no problem. This
I would say, if you're worried about security, the reason the restrictions for the REPL tool are there are mostly around security.
Yeah, it's a bit too restrictive. I couldn't do a lot of things with it.
It's true.
Yeah.
That's
why at first I wanted to use REPL for the demo, but after I tried it, I got quite frustrated with it, so I created my own. So this is basically, REPL is to run the code. So this generator tool generates code like this. So if you ask it to generate 3+5, you can even ask it to generate other stuff like, give me a plot of x squared. So it will generate the code that will use matplotlib. I mean, if you want, you can say using plotly. And then we use a plotly code, plotly graph like that. So it's very cool. You can just give whatever instruction you want. It's like typing in the GPT terminal, and then out comes the code. And this is done using a function of TaskGen. And this function of TaskGen is actually using StrictJSON. So StrictJSON allows you to do code, and it does code pretty well. In the latest version of TaskGen 2.3.0, I put a type code here that will take away any backslashes and basically any escape characters that might affect your code. It will go here. The reason why I put it as a type code now is because as StrictJSON gains more popularity, people have been telling me for non-English languages, this decoding of Unicode has affected the output. So I've restricted it to code now. So only when you put type code, then I take away the Unicode escapes. Right. So this is updates for 2.3.0. So just letting y'all know. Okay, so the Python run tool is basically, I asked GPT, how do I execute code safely? And then it gave me this answer. So I imported whatever that I think like is useful for most things like plot graphs, read CSV files, so you can put whatever you want here. So I recommend if you want to do this run to, you probably will copy and paste your own function here and use it. So you can put whatever you allow, whatever functions you allow here. Only those you allow can be used by the LLM. And I specified this here. You are only given this. Okay, so this is the Python run tool. You can say like, oh, this is a great tool to run in debug code, and you will print out this. Right. So we also have the debug tool. So debug tool is using StrictJSON again. So it comes out with the current code and what's the error message, and then it will debug. Right. So this is an inbuilt like debugger. So in the future, this run tool, debug tool, and generate tool can all be a single function called generate code, generate and run code. Then you can put all these three in a fixed process with error checking and so on. So I'm just putting it separately just to show you how this can be done with just off the shelf, just defining functions like that. So one cool thing about TaskGen is that you can define your own LLM-based functions just like this. Just like this. Can you see that? Just like this. Description of function with the input variables and the type here if needed. Output format you want, and optional, your function name. So just like that, you get your LLM function. So it's super cool. I've been using this for over a year and I still like it. Yeah. So I mean, there's personal bias because I created it. So but I really like this way of doing it. So yeah. Here we have a get text from URL tool, which is basically the same thing as the WebScraper tool from CrewAI, but I just put it here so that, in case you want to scrape websites that require a bit more nuance, like you need to wait for the website to load before you scrape it, like for those JavaScript, sometimes it takes some time to load, you can actually wait here. So again, this is generated using ChatGPT, GPT-4, and it works better than like a typical web scraping tool. So I just put it here so that, this can be a default tool for TaskGen. In the future, in the near future, we will have a community store for tools for TaskGen. So people can just load their own tools and download other people's tools. And these tools will all be parts of like tools.py, which you can just copy and paste the stuff, or you can just import this as an import statement. Okay, but if you want more versatility, I recommend that you just take the copy and paste the code and edit whatever you want inside yourself. All right. So this, you see, this is so much more flexible than if you were to use like Crew.AI. You only have access to certain things. Like if you look at this Selenium scraper, you only can have access to like this other stuff. All right. So of course, there are pros and cons. If you want more specific stuff, you can copy and paste that code also. It's open source for CrewAI. Or you can create your own functions like this. Yeah. So I'm trying to move to an ecosystem where we create our own functions and share them as well in TaskGen. So this is how the agent I'm going to show here. This is the generalist agent. Helps user with tasks, and then when deterministic output is needed, regenerate code and run it. So this is the first showcase of code generation with TaskGen, and enjoy. So here, I'm going to ask it to, generate me a graph of y equals 2x squared. And you can see that first it generates the Python code, right? Next, okay, by the way, this is using ChatGPT, okay? So ChatGPT can do this already. So next, run the Python code and visualize the graph. And then graph has been plotted and task. Done. Sweet. You see y equals 2x squared. Is it correct? I think so. Yeah. I haven't checked it, but it should be correct. Yeah. So this is just a showcase of how the like you can just generate and run code like that. You can't use the REPL tool for this. REPL tool can't do this. That's why I created my own run tool here. So you can see, and this is made to be as safe as possible. But as what Richard said, like maybe we might not want to put pandas or NumPy because it might access files, Yeah, so stuff. Okay, so next we can ask it like, what are the first 10 prime numbers? So I'm just going to run the code here. Later, you can just tell me your own task. We see that it works. So first, we generate the Python code for prime numbers, right? Then we need to run the code. So can you see that in the previous version of TaskGen, this would probably fail because like it probably won't be able to generate the plan out like that. Or maybe it would, but if let's say the plan fails halfway, it won't autocorrect itself. Here, now its prime is not defined. Okay, so great. We ask it to define this in the code. Okay, and I think right now what's happening is that this is not it's only defining is prime, but it's not running it. So let's try running this again. Okay. So sometimes this happens for ChatGPT. So let's take a look and see whether this works. So my recommendation is that if you are using code, try to use GPT-4. It works better, much better off the shelf. Okay, we have a problem here. Its prime is not defined. I wonder why. Okay, so this might be an error with this. Okay, let me just copy and paste this code here. Okay. So this is good to debug because this didn't happen for me when I tested. So let's see what's wrong with this. Okay, so print this out. Find its prime, and then we run this code, and then we get this. That looks correct to me. Why did it fail? Okay, let's do a very unsafe thing and execute this. It works here. Okay, so apparently this run tool is not able to run this. Okay, I have no idea why, but let's try it. Python run tool. This prime is not defined. Okay, so maybe something to do with the globals. Yeah, but let's try again. Let's try again. So yeah, I'm going to try to generate this again. If not, I will debug it off screen. Okay, the main thing is the code is actually correct. It's just that the run function is not able to run it. Okay, if you just execute it, it should work. Okay, so this is the graph of y equals 2x squared. Now we do the 10 prime numbers. Okay, let's see. Okay, so we still have an error here. Okay, the name is prime is not defined. So if if you all know why this is happening, do let me know. If not, we're just going to skip this and move on to the next one. Okay, so they are trying to see, at least they're calling the debug tool well. So they're trying to debug it. Okay, and then it's still having the is prime is not defined. So is here is definitely defined here. Just not sure why it's not able to run this code, because it looks fine to me. And I don't know, maybe something wrong with this run tool. Like okay, anyway, not a problem. Let's move on to the last one. So it's like, if you want to ask like certain stuff, like search for Wikipedia for Joe Biden, ask how old is he. So this is something like the math QA data set. You can also use like code to calculate. So over here, it calculates the age difference between Joe Biden from today's date. So the age is 82 because they just take the year, which is correct. It depends on whether you want to take the year or take the month. It could be 81 or so. So here we have 82. So print out the age to the user. Okay, so the answer is 82, and that's great. I mean, you can just put this agent.reply user, and you can see that it's 82. So this is cool stuff. Lastly, we can also ask like how many stars are there in the TaskGen GitHub. So if we have the WebScraper tool assigned to it, okay, so we will first scrape it. So I'm using Selenium headless browser, and basically we scrape this text here. Then we can extract. So now we have 76 stars, and that's it. So you can then reply the user also. Like after this, you can just reply user. There we go. All right, so that's more or less an illustration of like how to do code generation, code debugging, and so on. The is prime issue, I'll try to figure out why. I guess it's something to do with the restrictions that I've placed. So previously, I didn't place so many restrictions. So I guess the more restrictions you put, the less flexibility you have with running your code. Okay, the last part is LlamaIndex. LlamaIndex, basically, there's stuff like core tools, the same thing, you can do like function tool dot from defaults, and then you can define your own function as these core tools. Okay, I won't go through this because this is similar to how we do for LangChain. You just wrap it over a function and use it. Questions so far for what you have seen, or anything you want to ask? Okay, so I'm going to show you the next one, all right? This is the next demo I'm going to show you. So again, you first go to TaskGen, you put your own API key here. So we're going to use 4.0 for this because we are generating code. And so for this, let me just show you how to generate this code. So I want to create a PyGame where you control little red square, avoid orange circles coming at you from all directions. You have 3 lives. Your aim is collect 3 green squares to win the game. Do a UI at the top to reflect the scores and life. They output the final code to me that can be executed with exec. Okay, so this doesn't use code generator. This just uses an LLM to generate. Of course, if we can put the code execution functions, maybe it will work better. But this is just a rough idea of how to do stuff that is even more detailed than usual. Okay, you can just put this here. So GPT 4.0, if you use ChatGPT, this wouldn't work because it's a bit too complicated for ChatGPT to handle. So we can have this, like get LM to perform this, controllable red square, and so on. Right, so let's wait for it. So yeah, I just want to showcase, like, you can do quite complicated stuff by just overloading your task here with a very specific task and use a good enough LM. And it should be able to help you to, like, if you want to brainstorm ideas, write essays, and so on, you can just put your very, very detailed task here, and TaskGen should be able to do it for you. Okay, so this is what it is now. Code here. Oh, that's it. Okay, so sometimes it iterates over a few cycles, but it seems that GPT-4 is able to generate one shot the code. So we can reply the user what's the output, and then we can execute this code. So let me just stop my share now. I'm going to share my entire screen so that you can see whether the code runs. Can you all see my screen now? Are you able to see the screen?
Yep, all good.
Okay, so what I'm going to do now is I'm going to ask it to reply the user, which means that it will reply me the code that can be executed. Okay, and I'm going to do a very unsafe thing right now. I'm just going to execute the code. So do not do this for agentic systems you create commercially. I think you might break your system, but I'm just, because this I already know is it's just a game. So yeah, it looks okay. It looks all right to run. All right, it doesn't look very dangerous. Okay, so let's just run it. All right, so let's see whether it works. Okay, so this is the game right now. I don't know if can you see the game?
Yep, all good. Coming through.
Okay, there's some issue with the lives adding. So, but the thing is, they also created green squares. And yeah, I don't know whether I died. Okay, so it's supposed to be orange circles. It became orange squares. Okay, let me stop my share again. Okay, because my screen is. Okay, so I actually did something that. Okay, hang on. Let me just do something. So I actually just created a game just like that. Like, okay, granted, it's not exactly 100% the same. Okay, so what could be done is, we could add in other stuff like an agent to reflect on the tasks. Like, so other than generate the code, like if you put in some functions here, like generate code function, reflect function, as long as you give it some stuff to do reflection, or even in the task here, just say, after generating the code, reflect and see whether it's correct. Yeah, stuff like that could actually help to improve the output, right? But I'm not going to show it right now. Okay, so this is just an example of how the code can be generated just like that. Okay, we can also write an essay. So write me a 500-word review on this. Okay, so the review on the important dates of LLM releases should contain the company LLM as well as the capabilities, and analyze which LLM is the best for entity extraction. So notice here we only gave it Wikipedia. It would be better if we gave it like search the web. We haven't integrated the search the web yet, but this is like more or less how you do it. This is the output. You compare the LM models and then write a detailed review. So this, by the way, is ChatGPT. So if you want better output, you can use ChatGPT 4, GPT-4, which gives better quality. So this is the detailed review now. All right, let's see the output. So again, if you have a reflection loop and so on, this actually might work even better. So you can implement a reflection loop as a separate function to reflect and give critique. A critique function actually helps a lot based on what other agentic frameworks have shown also. Or you can put the critique as part of the pipeline. So how do I do a critique as part of the pipeline? You basically at the end of your agent, you ask a StrictJSON function to critique this one. And then you pass the critique back again here. So you can put like pass essay is this, and then your critique is this. So you could do that as a loop. Okay, in the future, I will think of a way to make this even better with a global context. So you can put in your agent's global context, you can put your past essay, your past critique, and ask it to improve on it. So there are many different architecture styles of this. It's quite open. Okay, I don't want to fix to a certain style right now, but I just want to show you that a very long prompt like this, it can still reflect upon what's needed in this task. And it does pretty well, actually. Like it went to Wikipedia, extracted the stuff, compare the LLMs based on performance. And this is grounded in the Wikipedia article. And we get our, is this the thing that I executed? Yeah, we get a reply in the end. So the timeline is this. So maybe over here, this is GPT. ChatGPT that doesn't reply in the 500-word essay format. So yeah, it's still it's not as good as GPT-4, yeah, but at least it showed like, oh, there are other companies like Google, Meta, Anthropic, Mistral AI. There's also this DBRX by Mosaic ML, launched in March 27, 2024. Have you heard of this? Because I haven't tried this before, but apparently this is considered big. If you look at this, who here has heard of this DBRX? I honestly haven't heard of this, so this is something new for me also. So yeah, this is how we can get an automated web scraper agent. If you want to do research on papers, you can do it as well. Use the PDF scraping tool that I showed you all earlier. Right here, you have a PDF tool that can basically look at PDFs. Where was it? Yeah, it's the PDF tool. So you can use the PDF tool. You can use like file download tool. Okay, I think that's a bit risky, but maybe if there's a way to go to a web page and read the PDF directly from the web page, that might be better. So I have to go see whether there's such a thing, because I'm a bit wary about download tool unless you do a safeguard, say I only download PDFs. Yeah, so this one will need some advice from Richard how to do this securely. So
well, that's perhaps that's for another day. But there is, like, fundamentally, when you browse the web, you download files off the internet. So you're exposed either way. It's just a question of flavor. That makes sense. And how do you secure web browsing in general?
yeah, no worries. So with Richard in the TaskGen team, because he's helping the paper, we will incorporate his security wisdom as well, so that we don't accidentally download like viruses into your computer using TaskGen. But
we will mitigate the risk of.
yeah. So I hope today is actually mainly a showcase. The original plan was to create an escape room and to use the agent to solve it, but I'll leave that for next week. So I think TaskGen is very powerful once you equip it with all the right tools. And the way to equip it, let me just reiterate again before we end, is to just define a Python function and just write in the types that you want for your inputs. Okay, don't need the args and quarks, okay, and the output types here. So you can use typing to do the types, and then we will automatically put it into the required format for TaskGen. The other way to do the function is to do your own internal LM function. That's where you specify your description, your output format of what you want, the keys that you want and the values, and the function name. All right, so with this, you can just plug and play this function here into your assign functions, and that's it. Okay, you can also assign agents. Okay, so like you can assign agents, then you put your agent name here. So your agent can do like, you can assign another agent here. I won't be touching on this today because the inner agents is not fully completed yet. So once it's fully completed, I will let you know again. So right now you can assign agents. It's just that the auto summarize might affect the subtask completed because both agents and the inner agents share the same subtask completed for today. But in the future TaskGen versions, the subtask completed for the inner agent and the parent agent will be separate. So that's the next thing I'm going to do so that we don't overwrite all the subtasks that's been completed by the parent agent. Okay, so that sounds a bit complicated. No worries. I'll have a separate session to talk about inner agents again once I've completed that part. But for today, just take note, put any Python function you want, put it into assign functions, write your agent name, write your agent description, put a detailed task here in your run, and that's it. Okay, if you want to do more tasks, you can just reset and run another task. And you see, it works pretty well off the shelf. You don't really need to tune it much. If you want to, like, say, do certain things like end immediately after calculation, you can put in this description, or you can just put directly in the task. So just play around with it. It may not be perfect, but if you face any issues when playing around with it that you think is a framework issue and it can be solved with better prompting and so on, do let me know, because TaskGen will only improve if there's more people feedback. If I receive more feedback or the team receives more feedback, and basically we can incorporate those feedback and try to make the use case work better. So let me share a bit with you how I created all these prompts. So we go back to TaskGen. You look over here, there's TaskGen Ask Me Anything, TaskGen tutorial 0 to 6. So every time I change a prompt in TaskGen, I will test out with all these notebooks to make sure it's all still working. So the more you have to like give it the eval, the better the performances will be. So when you have your own stuff that does or doesn't work, you just tell me what works or what doesn't work. I also put that somewhere in the eval. And basically, TaskGen will evolve to be more and more robust and versatile. So at least I'm sharing with you the process. It's not easy to create a new prompt. Every time I test this, it takes 2 to 3 hours. But I think it's important to create at least a baseline agent that's what you see today here. Plug and play the functions and run it. So this took 2 months to create, so it wasn't easy. But I hope you have fun playing around with it. Okay, maybe the last 5 minutes, and anything you want to add or anything you want to see in future updates of TaskGen, now's the time to say. Okay, so if not, that's all for today. And yeah, do download the latest version of TaskGen, play around with it. Let me know your comments. If you haven't already, you help to start the GitHub so that we can have more people knowing about this. So that's all, and stay tuned for more updates. The community store for the, like, not community store, but the community upload for all the tools is coming soon. And that will be something quite big also. So stay tuned for that. And yep, signing out. See ya.
Thank you. Thank you so much.
All right.
Thank you.
Let me stop the recording.